quite a bit
Okay, stream seems to go. Well, you guys need to assess that eventually. But today it's not me talking, so you're in for a treat. This is probably the most important lecture of the semester because it's about professionalism in
no
C++.
pressure.
Huh? Okay. no pressure here, no pressure. That's why we're streaming it. So everyone who didn't show up in person lost out, that's for certain. There's the first question.
You definitely need to zoom the terminal in more.
We'll do
Terminal
that.
isn't important.
It was way too small. Okay, okay, never mind.
So anyway, that's Per-Morten. He is doing his master's right now and has considerable experience in well, C++ anyway. He did survive graphics before.
Yeah.
Any other features I need to highlight?
No.
Good. You guys know him? If not, then you will know him afterwards. So, well, the floor is yours. So it's all up to you.
Yeah. Well, professionalism is not necessarily all that I'm going to talk about, and probably not much. What I'm going to do is that I'm going to try basically highlight some stuff that you should be thinking about in graphics. We're going to do some because you've been learned or taught a sort of more like C++ style way of handling stuff. C++ has evolved a lot since, you know, the algorithms book was written. It's been published 4 new standards, I think, 3 or 4, and we're so yeah, 11, 14, 17, which came out right before Christmas, and now they started working on C++ 20. So the language is pretty different from what you guys learned. And I'm not going to go through all that. I'm just going to like pick out 2 specific features and then try to sort of, I guess, give some values to what sort of stuff you should think about. So I'm going to basically show you 2 cool C++ 11/14 features, to discuss a bit about the standard library and some general C++ stuff. We're also going to move over to then some like typical mistakes that we did when we did our graphics programming and that people sort of still do, which isn't sort of like they are easy mistakes to make and they might be a bit tricky to debug if you don't know what you're looking for. And then I'm going to give some general tips about stuff you should think about using C++ in graphics, or at least what we had learned when we actually did this. And then, you know, show you some good resources that you can look at. And obviously, if we're finished way too late, then, you know, we'll cut. So I won't go through anything. If we finish way too early, I'll just like improvise the rest. So that will be interesting because I haven't timed this. Yeah, so we can start with. So I guess whoever has done, you know, after the. Who has done C++ programming outside of the courses? Most of you. And who then has tried to like read up online on what is considered, you know, good practice or whatever? Okay, interesting. Yeah. So yeah, C++ is, you know, an interesting language. It has a lot of features and a lot of places that you can, you know, make mistakes. But yeah. So let's just go into the cool C++ 11 stuff. So it looks like I have like a short list of topics. I'm trying to go in live code everything, and if I sort of totally underestimate it and you obviously understand everything the first time I say it, then, you know, this will be a short lecture. So yeah, we'll start with like 2, I guess what I consider the coolest features of like C++ 11 and 14, which is first auto. Which is a cool new keyword, and also then lambdas. I'll show you auto straight away, but the lambda part I'll show you like how it looks, and sort of on the next slide show you where you can use it properly. So I guess we can then just like run straight into code. So obviously all of you guys are like used to us writing declaring types. So like int a is equal to 1. You know, everyone's seen that before. What you also can do post sort of C++ 11 is that you can write, you know, auto b equals 1, and then b is now an int. Obviously, this seems super stupid, saying that we're dealing with, you know, int, and actually writing auto is 1 character more. However, there are some real advantages to having auto. First of all, the auto type, or like B here, still has to be known at compile time. So, you know, if I try to do, I can't like write auto C, and then if 1 is equal to 2, then C is equal to 2, else C is equal to, you know, a string. That won't work. First of all, you're not allowed to like write auto this way, like without giving it a value, because it has to know sort of when you define it, what it should actually be. So writing auto C is equal to string, this is fine. Also writing it is equal to 2 is fine. Obviously the if statement breaks, so you can't like have something that is 2 different types. Just as you wouldn't be allowed to do that, you know, in the regular C++ language. So the places where auto really shines is if you're dealing with really complex types, or if you have some place where you're sort of repeating yourself. So if I say, you know, int pointer is equal to, or I guess like string pointer, or yeah, int pointer, ptr is equal to like new int and then 100. So in this case, we're sort of repeating ourselves because, you know, we can see that we're talking about ints here. So then we should be able to like do auto. Also, there are the other use case for auto is sort of the next one that we come to, which is when you actually don't know the type. You're not allowed to know the type. With auto also came a new sort of fun loop. So if you have, let's say, an array, a proper array, so if you go, yeah, we're going for the old readable names there. Usually you guys would iterate like that through writing int I is equal to 0, I is less than 100, I plus. Instead, obviously you all now are used to counting from 0 and not 1. And then you would, you know, access into I using that sort of syntax. What you can actually do now is that you can just write for auto I in C. And now we basically can write, so say we want to print out this stuff, then we can just write like that instead. So you're talking about sort of each object not as part of the array, but on its own. Right. So also, if there is any questions, please just stop me, because otherwise I'm just going to think that everyone understands everything. So, any questions about that? Yeah.
Will you still be able to pull like an index from that?
Well, no. So if you want an index, you probably want a different way of iterating through it. But there are, so this now is sort of like a new, if you want to pull an index, there are several ways to do that. So instead of writing that, you could write your standard, you know, sort of, yeah, int I for loop. Or you could use iterators, which I'll show afterwards, where you can use the standard library to actually get that index out for you. Also, everyone here obviously remembers call by reference and call by value, right?
Yes.
Who is it that don't remember that stuff? Is there anyone? No? Also.
So I do it in a representative for all the ones that are sitting on the stream and would answer no.
Okay, so call by value and call by reference basically means usually if you're doing like a function call, so one func int b, and then you know b is equal to 2, and then down here if we like I'll just remove the a's and b's so that I can reuse those, obviously. If I now say func a, and then I like C out a, so what will, well, this as well, so it's not undefined behavior. So the question, like the basic way of showing call by value versus call by reference, is in this case, what do I print out? So in this case, I will print out 0 because when I call func, it will take a copy of the value b, or the value in a, so give it the name b, and then operate on that. So you know, I won't actually change the a value. However, if I do this by reference, then I will print out 2, because I send in the actual value of A. Yay! I don't know, this is forgot to include CL, so we can't actually show it. Cool. Yeah, so 2, and all the other is garbage from the array. Yeah. The thing is that sort of call by value and call by reference now also extends to loops. So in this case, this auto here is a call by value. However, if we do like auto ref, then it's called by reference. And this is sort of where we're getting to territory where I'm not that familiar anymore, because there is also a way to like write auto ref, which might mean something else, so don't arrest me on that. However, I'll always usually just go for auto ref, and then usually also const auto ref, because I don't usually update my variables in the loop. The reason I use const auto ref, or instead of like auto ref, is I remember a long time ago, 1 year, we had a problem with like saying const auto ref. So yeah, that might also just have been like a bug. We didn't really check it out. We just hacked it and made it work. So yeah, auto ref if you want to change it. So in this case, if we want to zero out everything, we could say like I is equal to 0, and then we would zero out everything in the array. Right. Everyone's good. Okay. Yeah.
Why do you need auto ref in order to set I to 0?
Because if I just do like this, then I won't actually set the I in the array.
Oh, right.
I will copy an I and then set that I to 0.
Oh, right. You say whatever address I now is. Okay.
Yeah, reference it. Yeah. So, and that's also sort of fun, because we had someone that made a huge memory leak in OpenGL by doing exactly that mistake. So they had written like vertex object, so they created like a wrapper class for a vertex object, which in the constructor would allocate all the space for the vertices, and then obviously they would, or I don't remember exactly how it was, but it was like a because of that loop, sort of. It was that I think in the copy constructor of the object, they still, recreated all the vertices or something and sent them to OpenGL. And then they actually, got a huge memory leak because they would always take copy, or take a copy of the value in the loop. So, if you are doing this in Visual Studio and you suddenly see like linearly that your memory usage is rising, that might be, perhaps you have done a mistake sort of like that. Yeah.
I think there's a comment here.
Yeah.
Sorry. So const auto ref.
Yeah.
That will not change anything.
No. So if you const auto ref, this isn't legal anymore.
Yeah.
Then I can only like read from the variable I can't assign it. Yeah. Any more questions? No? Okay, so that's the auto syntax. The reason I'm like, my sort of view on it is use it when you have to and when it enhances readability. So readability is always key. So if there is any case where you think that, hey, I actually get much more information of having the type here, then, use it. But there are some people who are like advocating the always auto or almost always auto, which is, I guess, a bit controversial or something. But yeah.
Is there? I mean, generally, it's always this discourse between dynamically and statically typed languages, right? So, and doesn't it fall into that bracket as well? That you suddenly have if you have a larger code base, that you get issues with maintainability if you overuse auto? Would that be an intuition you would follow, or not really a problem in C++?
So my view is just to use auto when I think it enhances readability. And if the code base is large enough, like if you're using an IDE, say Visual Studio, then that will always give you the type anyway. So that's not really an issue. But some people want to know the type, And even if you're not using an IDE, so if you're like using Sublime or something like I do, if I actually need to get extra information out of the type, then I'm also usually, say that I return a type from a function, then I'm also usually interested in like how that sort of object came to be, so I'll just go and read up on the function anyways. But that's, you know, different approaches. But the language is like, it's still statically typed, so auto doesn't change any runtime behavior. It still works according to the same rules as everything else, so like you're not messing with the type system or anything. Yeah,
Yeah, that was the
yeah.
okay.
Right. About the stuff I'm putting out on GitHub afterwards, I probably won't put this out because it's, you know, yeah. So so that's auto, and the reason that you guys sort of need to know it is because we have finally gotten lambda syntax in C++, and in that case you're actually not allowed to know the type. Like, you can't know what the lambda is. Or I guess first, who knows what a lambda is? Okay, so the sort of easy way of explaining it is a lambda. It's written like, you know, this. Screenshot. That obviously has to be included. So this is how a lambda looks. Essentially, a lambda is a scoped function, sort of, or function object kind of thingy. There's like a lot of different explanations to what a lambda actually is, or a lot of different ways people say it. So I prefer to look at them as like scoped functions that you can assign a name. So in this case, I can, you know, write, I can like see out hello, and then later I can call that like this. Yeah. Which should then print hello if I haven't really messed anything up. Yeah. Yeah. So that writes hello. Obviously, you guys are probably asking, okay, so why don't we actually use a function? Well, you know, the lambda has some cool properties as well as some other cool properties as well. Which is that I can bring with me I can bring variables with me into the sort of function call. So I can write like if we take my name, so you know, like that. I can, and then we say that we take name by reference, which sort of now it starts getting confusing because now I'm suddenly putting the ampersand in front of the name, which is basically just because, you know, C++ syntax is, you know, weird. So now I can write there, and then I can take the name in with me. And so basically I can start bringing variables with me from the outside. And I can still also call stuff if I want, or like send in parameters when I'm calling it. So if we're saying like that we all are also bringing in like surname, then I can say that I can print out name and surname, and then I can call this with Straume, and then this will print out hello Per-Morten Straume. So basically, it's sort of function type that I can introduce other stuff to, and I can hand it off to people. You can, you know, return this from functions, etc. And give them out. So the place, and yeah, you're not actually allowed to know the type here, so I couldn't like now write, you know, like, you know, lamb or something, lambda, and that is, you know, equal to lambda, or sorry, L is equal to lambda. Like, this won't work. I don't know what type lambda actually is. So here you have to use auto. There's no actual choice. And if you go into like Visual Studio or something and hover over it, or if you look in like debugger, you'll see that it has some like weird name, which is just like randomized characters, etc. And that's different for each compiler, or can be different from each compiler. So there you just have to.
Yeah. regarding like the parameters
Yeah.
to the lambda function.
Yeah.
You sort of have two ways of bringing in variables from the outside here. You have the sort of the bracket thing, and then you have sort of traditional parameters.
Yeah.
So that was very confusing for me at first.
Yeah.
Then, do you have any intuition to when you should use one of them and when you should use the other?
Sure. You can. So I'll come with an example, sort of extended example soon. But one way is say that I have, and that's sort of where we get into functional programming. If I have, you know, a function that returns a lambda, so this will be fun. So let's say that we have some sort of, we have a static int counter which is equal to 0, and then we like return with counter, we return counter plus plus, or like that, and then hopefully this will actually compile. And then you're also taking like a string, I guess, which is, yeah, we'll take in the name again, and then we'll say auto res is equal to func, and then it's a res test, and then after we'll, and then we hope that this works. Yeah, also, here's the fun part now that you're getting to like more advanced C++. Error messages are going to be a lot more fun, as you see. So, what's the actual problem here? No problem. Ah, shit. Well, that is a case where you would have used it. Basically, you can do it to like, if you want to, so basically it's called a capture list, essentially. So if you want to capture stuff from different scope, so I, for instance, have a resource that I want you to access, but I don't want you to, see it. So you can say that I, instead of doing that function thing, we can actually simplify this a lot and just say like, if I create the add by, or add by, and then I want to like create a function that adds everything by 2, or some number. So in this case, you could say like return a plus b, and then a is something that comes out from outside, and a is equal to 2. And so if I like, because that function stuff I tried to do earlier, it should work. When you figure out the syntax and all the compiler errors. So in that case, you could do like, there's a resource I have that I don't want to show to the outside world. So it sort of delves into functional programming and doing like captures there. But the place where you will probably find it most, which is where sort of the lambdas get really interesting, is if we start talking about standard algorithms. So I'll move over to that topic, which is the next one, which is the standard library. So I'll just start with algorithms, and then we'll go back to string and vector afterwards. Or we'll start with string and with vector. So string, I hope everyone has sort of been longing for that feature. yeah, now you can use it. We actually want you to use it. In general, we want you to use as much of the standard library as you can, because you're here to focus on graphics and not create like memory leaks in string code, or create other weird bugs, etc. We want you to have bugs in your graphics code, not in your C++ code. So use all the standard facilities that can help you ensure that you avoid those sort of bugs. So now you have strings. They function really sort of obviously, so you can create them. Here's a string. You can do quite a lot of operations on them. So you can ask them for their size. You can check if they're empty, and this is sort of where it gets perhaps a bit confusing from people for other languages. You'll often see people who are new to C++ or whatever write str.empty, and then they're sort of like trying to empty it. And that's not actually how this works. You're supposed, like, this returns a boolean stating whether or not the string is empty. If you want to empty it, then you use str.clear. You can iterate through them as well. So I can say like for auto, for each character in the string, we want to see out it or whatever. And then I should do many decimal. So it's possible to do that. And say no to power anymore, and then actually oh yeah, right, we cleared it, so obviously it's not going to have anything in it. But here, it says here this is a string by sort of iterating through it. It also comes with all the other functions, the cool functions, so you can like say string dot. Just look up the functions here. I think it is just string dot find, and then you can search for characters. Yeah, find. So I could just say like search for the letter I, and then I should get told where that is. So the letter I is the first letter I is in the 5th position. So. The cool thing also with string is that if you need to interact with C libraries, etc., there is actually a handy function for that. You can write string.cstring. So we actually did this when we had our object-oriented course. We used string everywhere, and each time we needed to interact with list2 or whatever, we would just write like string.cstring, and then you get the actual C string out. Yeah, and then. So that string, there's a lot of algorithms on it. I have written up this page as sort of like a must-read. This is CPP reference. Basically, when I started working for my first summer job, we were told that this was the one that sort of trumps everything. This also like trumps Stack Overflow in 90% of the time. The only problem with this is that it's a bit hard to read until you actually get used to it. I guess the first tips is if you see something that looks like this, then just don't unless you understand what's happening there. So I sort of understand what's happening there, but if you haven't seen templates or anything ever, then it's really not that important. Usually the stuff that is here isn't necessarily as important either. That sort of depends. You shouldn't need to know as much about the type defs anymore because you should be using auto. The cool thing is that it also shows you here like what standard they're from. So if you find stuff where it says like C++20, then you probably shouldn't use it. And also, if you find stuff that is C++17, although that standard is published, I would still be a bit unsure about using it. Just because it's so, like, a lot of that stuff is really stable, but suddenly someone comes along with like hasn't updated the compiler or whatever, and like either Peter or Christopher hasn't updated the compiler, and then they can't run their program, and people who grade your assignments, you prefer them to be happy and not have to download extra software to run their stuff. But if you guys are running on sort of recently updated stuff, you at least have C++ 14. Yeah.
Yeah, so we should compile with 14.
Yeah.
Yeah.
I would say so. I haven't moved over to 17 yet, but I probably will after a while.
But if we use the CMake files, then the actual lecturer decides what compiler we're using.
That's right. So for our side of things, but if you write them,
Yeah.
so for your the compilation, then yeah, you need to make that call. But yeah, we can.
I am not the one who's going to correct the assignment, so it's obviously up to you. But also, it's like not necessarily everything in C++ 17 is implemented across all compilers. And the last time I checked, the sort of C++ 17 version of the standard library wasn't necessarily implemented everywhere, even though the language was. But here, yeah, so here you see everything, like all the functions that the element has with cool, cool explanations. So in this case, CString returns a pointer to a null terminated character array with data equivalent of those stored in the string, etc. So and usually it also shows like examples, which is also good. So that's string. The next one is vector, which will hopefully be your favorite container. It should. And I can find it. Where did the vector go? Oh yeah, containers library. So yeah, vector. So you guys obviously remember like new and delete arrays, etc. And you use that to create different arrays. So vector is basically a dynamically sized array for you, which is pretty neat. So, I can say that I want a vector, like int a. So, from experience, or not a, I call it vec. Yeah. From experience, most of you guys probably does not know how many people knows what this means. That I write like angle brackets and I, or int. No? Okay, yeah, some of you know, but not everyone. Because I don't think Cody mentioned that at all in the classes, did he? No, okay. So this is one of the, a really important feature of C++. It's called templates. I won't go far into it. Basically what it means is that, for instance in this vector, the way you use it, you can now write a vector of everything. So currently now I have a vector of int. If I write float, I now have a vector of floats. Or if I write stud string, I now have a vector of strings. And this is not a mathematical vector, even though it sort of sounds that way. It's like a dynamically sized array. So yeah, so that's how you guys will use templates for the first, I guess, in the beginning. And then if you guys want to know how templates actually functions and how to write your own template stuff, I can probably tell you about that, but not now. And also this is again where people, one of the few arguments in favor of not teaching you, the standards, etc. up front is that these error codes that we had earlier, if you have stuff in your types, so say that I create a type that you can't copy or move, which is possible in C++. Then I'm probably going to run into a lot of these sort of errors, which are relatively hard to read. I guess we can all sort of agree on that. The most important thing is just start at the top with the error and sort of see if you can get it to make sense. Yeah, and also look at CPP reference if you're you're allowed to do stuff that you're trying to do. But yeah, so a vector, if I want to add stuff to the vector, so I want to add the number 1, I can say pushback 1, or also sort of for the people watching and also you guys here obviously, there are more efficient ways of doing basically everything I'm doing now. So pushback might not necessarily be the best option in some cases, because there are other functions that might be better. But you guys don't need to care about that now, because you probably won't get to the part where you're actually sort of pushing your hardware, and I'm just trying to keep it simple. So yeah, pushback is one that you can use. You can also like resize a vector, so I can resize this to be like, you know, 30 big, and then it will allocate the space it needs and copy all your stuff back into that. Yeah. And then you can also iterate through it and all that. So just seeing as I'm, you know, going on and about time. So for the next one should then be the algorithms. Or is there any questions about vector? Yeah.
It's the easiest way to print a vector.
Iterate through it and print it through that. Yeah.
For each.
Yeah.
No. For auto.
Yeah. Which is a for each loop, basically, because it always goes through. And one of the cool things about vector is that vector will actually allocate more space than you need, sort of dynamically, so that it doesn't have to always copy your values. Yeah. So then the algorithms part, which is the next one. So obviously now you've gone through your algorithms course. So if I ask you to sort something, what's your first instinct? Okay. That was sort of not what I wanted to hear. You're sort of, unless, because now you got access to this awesome algorithms library, which comes in C++, which if we go to the algorithms section of CPP reference, and we go down here, you can see that in the algorithms library, there is a sorting method, and it's actually a pretty good one. So if you click on that, you know, it sorts, it gets, it takes in two parameters, first at least, random iterator, or random it, which stands for random iterator, first and last. And it has some cool complexity requirements, so it's actually required to be n log n no matter what the case is, unlike, for instance, quicksort, which is sort of just n log n on the average level. So if I want to sort this vector, so let's say that we yeah, we'll just so here's also one thing. If you're going to actually do the old style iterating loop with like for int, etc., don't use int. Use if you're using standard containers, then they don't actually use int. They use one form of unsigned int, which you don't know what it actually is, but it's sort of always type def to size t. So you should say like size t I is equal to 0, I is less than vector size. And the reason you should do that is otherwise you'll get like warnings from your compiler saying, you know, hey, you're comparing an integer with an unsigned integer. That's just a lot of noise, and it's easy to fix. And looking at that noise isn't like it's just in the way when you get actual trouble. So I could say like vector pushback again, and well, obviously now it will be sorted, but if I want to sort it, I can say like std sort vec.begin and vec.end. So in this case, it will sort it. Yeah, it will sort it using operator less than. So it will sort it as. Yeah, right. Std sort. Also important, include the correct headers. So include algorithm. Oh yeah, maybe we should actually. What? Sorry, 100, not vector size. That doesn't make any sense. Yeah, so that's at 10 instead, so that you can actually see it. There. So yeah, so now it's sorting it. So in this case, it's sorting the vector. Yeah.
Would it be more efficient or okay to have the terminal and the editor on the same screen?
Sure. Good point. Yeah. So now everyone sort of sees that it sorts. And this is sort of where the lambda comes into play, because now I've sorted it in ascending order. If I want to sort it differently, then what am I supposed to do? Like re-implement the sorting algorithm? No, actually, since C++11, we also have that there's, if you say here, it says like it takes in a compare. And basically that means that you can send in a lambda to it and use, or not necessarily a lambda, you can also do like stuff in like C++98, which doesn't have lambdas, but I just always send in lambdas. So it says that it has a compare, and down here it says like the compare should return a bool, and it should take in like type 1a and type 2b or whatever. It basically you sort of send in a comparator function. Or in this case, I'll just take int, which is left hand side, and I'll take another int, which is the right hand side, and then I'll return if less if the left hand side is less than the right hand side, and which should give me the same result as I had earlier. Yeah. So if I want to sort this descending instead, I can just do like larger than, and then I get it in descending order. Any questions about this? Yes?
Why are there 2 ones in the...
Oh yeah, it's just because I wrote one error. Yeah. And there are more stuff like this. So say that I want to find, so that's sorting one. Say that I want to find the first element in the vector that is divisible by 2. In that case, we have another algorithm, which is the find if, which is I'll just do this one and then remove it, and then we'll sort of move on. So say that I want to find the first element that is divisible by 2. So in this case, I'll say, the find if function returns an iterator. So it basically, in this case, you can think of iterators as pointers in a vector. That is actually the case, but not necessarily in other places. So we can say like std find if vec.begin, vec.end, and then if we then want to find everything that is divisible by 2, we can item return item mod 2 is equal to 0. And this then will return an iterator or a pointer to that element if it exists. If it doesn't exist, which is why we're doing this if statement here, so we do like if iter does not equal to vec.end, which means that basically if we have found something, then we output it. And seeing as with pointer syntax, so we're sort of dereferencing it. And if we run it then, 8, because they're sort of descending. Okay, yes?
The find if function, is that comparable to the filter functions which you can find in other languages? Filter? Or no, you find
no,
one?
Because you only find one.
Okay, yeah.
Yeah.
You find the first?
Yeah.
Ah.
And then the last one is if I want to remove everything, say that I want to remove everything that isn't divisible by 2, or remove everything that is divisible by 2, sorry. I can do that as well. So with the algorithms library, So then instead of doing, and this is sort of where it gets a bit more involved. Instead of doing find if, we can do remove if, which takes in, it sort of takes in a predicate or unary predicate, which basically means a function that takes one object. So yeah, if we do then remove if, begin and begin and end, and then it takes in this function, seeing as we're removing everything, where basically this function returns true. So remove if, even though it names as remove, it won't actually delete anything. It basically just sort of puts everything that can be deleted at the end of the container. It doesn't change its size. So it's sort of misleading. So this is where it gets a bit more confusing, because I basically now have to say like vec.erase, which is the one that actually deletes stuff. And I could do this, but that so if like the vec.erase either takes one iterator or it takes an iterator pair, and you usually want the one that takes an iterator pair, and in that case you have to also say like vec.end at the end here, because you're saying where do you actually stop the container, so stop searching, etc. So I guess this was a lot of information with a lot of new stuff, quite fast, so I don't know who's still sort of with us. Is everyone still ish?
5 minutes break or something?
Yeah. And then afterwards we'll go over to more like high level, and I'll this is more stuff that can help you, so the next should be stuff that actually helps you, like don't do this error.
Yeah.
Yeah.